Welcome to my Home Assistant tutorial. In this part I'm going to show you how to build, connect and configure a Waveshare Modbus device for a more reliable interface between Home Assistant and your solar inverter. There are many ways to do this, but this video will focus on using a Waveshare RS485 Modbus to Ethernet interface connected to a Solax G4 solar inverter. This may also be used to connect to many other brands of inverter such as Solis, SME, Growatt and Sofar. So what is a Modbus interface? The data ports on the inverter have the same physical RJ45 socket as a computer network, but if you connect them together they'll be damaged. The pinouts and the communication protocols are very different and need converting. So in simple terms, this Waveshare device allows you to convert inverter speak into network speak so that they can talk to each other. I'm not going to delve into exactly what Modbus is or how it works. I'm just going to show you how to build the interface and set it up. If you've been following the tutorial, you'll now have Home Assistant set up to communicate with the Wi-Fi dongle on your inverter. This is great and the easiest method, but the Wi-Fi dongles are not the most reliable for inverter control and communication. The Waveshare offers an alternative, much more robust connection which will not fail when the Wi-Fi dongle goes down or the Wi-Fi network goes down, which in some cases is quite a regular occurrence. You can keep the Wi-Fi dongle working so that Solax can update the inverter firmware and it keeps updating the Solax app in case you need to use it. Firstly, I'm going to look into what components you need to build the Waveshare interface and also what tools are needed to build it, and finally how much it costs, and then we'll go through the configuration of it. So what are you going to need? Firstly, you need the Waveshare interface. Waveshare make many interfaces, so make sure you choose the right one. You need the RS485 Modbus to Ethernet version. They also make a power over Ethernet variant of the same interface, but that's not required as the Waveshare will be powered from the inverter. You'll also need to put the Waveshare in a suitable enclosure to mount near your inverter. I'm also going to be using two RJ45 panel mount sockets to mount on each end of the enclosure so that it can be plugged in and unplugged at any time using a couple of patch cables. You'll then need two very short Cat5e patch leads, or you need to be competent at crimping your own RJ45 connectors onto Cat5e cable to make short leads. I'll go through doing both of these options. After you've finished the wiring, you'll need to connect the Waveshare to the inverter and to your network, so we'll need two suitable length Cat5e patch cables for doing this. The total component cost is about £60 for this project as I'm making it, and it should take about 30 minutes to build. Of course you can omit the enclosure and RJ45 sockets to make it cheaper. However, this one is being made for somebody else, so I wanted it to be robust rather than just dangling on the end of some tiny wires. You're going to need some basic tools to follow the tutorial. Firstly, a drill with a 25mm drill bit or hole saw, RJ45 crimper and stripper if you want to make your own Cat5e cables and do the terminations. You'll need a file for deburring some of the plastic housing, a small electrical screwdriver for the terminals, and some pliers to cut wires, and maybe a knife, a ruler and a pen. So really just basic everyday stuff. Once you've got everything prepared, let's get started building the device. What I'm going to do is take the Wilex box and the Waveshare. I'm going to mount the Waveshare in the box like this, as it's a DIN rail mount, and I'm going to take both of the RJ45 connectors, one to go to the inverter on one end and one to go to the router on the other end. Actually, I haven't decided which end yet, and hopefully all that fits in there. Now what is important is that I just get these in the right place on the end here, so I'm going to mark a centre for the hole and drill that 25mm big. I'm just going to put a marker 20mm up from the bottom, like that, and in the middle, which I think is 40mm. Because it appears to be about 80 wide, like that. And I'm going to just use that there as the centre of my hole. Nice and crude, look at that. You can see these holes are pretty rough. I could probably have done with a hole cutter rather than the spade bit, but it's just really the nature of this type of plastic. I'm just going to use a file now to just to take all the burring off the edges. The other end. It's better. That's absolutely fine. The flanges of the RJ45 will cover all sins. Okay, so it's just going to look like that. So take the nut off the back of the panel mount connector and place it through the hole like that. I've gone for that way up because it fits better inside the box of the Waveshare, but by all means put that way up if you prefer. And just screw the nut on the back. And the one on the other end. Just looking at the Waveshare a moment, all the pinouts are marked on the top in white here. So starting from this end, the first screw terminal is the ground, then we have the 485B, 485A, and the NC and NC are not connected on this version. On the other end, you have the voltage in plus, voltage minus, and then we've got the RJ45 connector out, which goes straight to your router or Wi-Fi router or a repeater or whatever you want to do. The red part here is just to pull in and out to unclip and clip on the DIN rail. This Waveshare doesn't need a separate power supply because we're going to power it off the 13 volts that comes off the inverter. You can power it from anywhere between 9 to 24 volts, so 13 volts is nice and in the middle, and it's just going to come straight out of the RJ45 port on the inverter. For ease of explanation, I've decided that this red patch cable is going to be to the inverter and the green patch cable is going to be to the router. Okay, so that's to your network. The green one comes straight out of the Waveshare and straight into the connector. So really all I'm going to do is take this small green patch cable, plug it into here, wrap it round underneath at the bottom so I don't need to do any crimping, and plug it into there. And that's all that has to happen to the green one. This is a prototype, just put the wires in any way you feel is best. It doesn't really matter exactly where they run. So I'm literally just coiling it up in the bottom there. There isn't any point in cutting this off because it's so short anyway. So I'll just leave it in the bottom of the mounting box. So that's ready for the Waveshare to plug in, which I'll do now just to show you. Plug it into the RJ45 port on one end like that, and then that's ready just to mount in the box. So I'm literally just going to clip it in there, push it down, and then slide it over to the middle. So the wiring for the one that goes to the inverter is a little bit different because we need to cut the cable, separate the strands out of there, and put them in the correct screw terminals. I need to measure how much wire I need to strip off the red cable, so I'm just going to put it into place. Firstly underneath, and fix it into its socket there, and then I can just loosely put the Waveshare in place, and I can see some of the terminals I'm going to have to fix at this end, and some of the terminals I'm going to have to fix at this end. So the wire has to be at least to here, and then I'll be able to strip it off, take the outer insulation off back to about this point, and I'll be able to secure them all. I'm now just going to strip the red cable off where I marked it, so just take it round there like that, and then I should be able to just pull the outer sheath off.
Inside a Cat5e cable, there are 4 pairs of wires making 8 cables altogether, and we are only interested in the greens and the blues. The oranges and the browns are for something else, and that's not what we're doing today. Now this Cat5 cable and the RJ45 on the end is wired to the standard of T568B. You can see in there orange stripe orange, green stripe blue, blue stripe green, brown stripe and brown in order of pins 1 to pin 8. So we're only dealing with pins 3 to 6. That's the green stripe blue, blue stripe green. So moving on to the Waveshare, we're looking at pins 3 to 6, and this is the diagram out of the Solax user manual. Pin 3 is plus 13 volts, so that's going to go to the V plus terminal on the Waveshare here. Pin 4 is 485A, so that's going to go to this terminal here, 485A. Pin 5 is 485B, and that's going to go to that terminal there. And the 6 is the ground. Now, a ground in DC voltage is essentially the negative, so that's going to come to here, and then we're going to run a short cable around from the V negative to the actual terminal marked ground, which is this one here. I've just put the cable back in the bottom of the box, and I'm ready to start doing the wiring. So the ones I don't need, I'm actually going to cut off, and I'm going to cut them off at different lengths. And the reason I do that is that they don't accidentally short out when you don't want them to. So I'm just going to randomly cut them off at about an inch apart. Sorry, that's 2.5 centimeters. Like that. So there's going to be no chance of those touching, and I'll just leave them twisted together. For the little bit of grounding wire, I'm just going to use a strand of leftover Cat5 that I've cut off. I'm going to take an extra strand of green wire now, and this is the wire that I'm going to run from the V minus to the ground around the Waveshare. Okay, it's green because the V minus comes to the Waveshare as green, so I'm going to continue it as green. So that I'm going to put alongside the other one and take a piece of the old sleeving that I stripped off and thread that through the middle of the sleeving like that. As I get to the other wires that I've cut off, I'm also going to feed those inside just to keep them all contained and protected. And push it up to there. And now we should have the 2 greens and the green stripe over here ready to connect the voltage. And we've got a green and the blue stripe and the blue over here. So the green is going to be the ground wire, and the blue and the blue stripe are going to be the 485 A and B. I'm going to put another small piece of insulation back on just to keep those ones protected as well. And now I'm ready to terminate them into the Waveshare module. On the Waveshare, make sure all the screws are backed off so you can actually get the terminals in there. Now just strip about 1 centimetre off the end of each one of the green wires. You can use a pair of side cutters, you can use a Stanley knife, whichever works best. It is a bit of a delicate job, so just take care and just take a centimetre off like that for each of the 3 wires. Okay, these wires are very delicate, so I'm just doubling up on them. So fold them over, and we're just going to insert them into the screw terminals folded over because they're so small. Just to double up. Just double them over like that. So they're ready to put into the voltage terminals. On the other end, I'm going to do exactly the same. Cut the wires off, strip 1 centimetre off the end and double them over. So take it to about here, cut them off, and then strip 1 centimetre off. So I'll strip the 3 at this end. I'm just going to twist them together because these are patch cables as opposed to solid core, so they're flex and they're multi-core. So just to stop them fraying, and then I'll cut them off to about 1 centimetre, and then just fold them over as before. Like that. So we're all doubled up and ready to go in the connectors. So I've put them in order of green, which is the V negative, the blue stripe, which is the 485B, and the blue, which is the 485A, and I'm going to wire them into the terminals into the Waveshare like that. A little bit fiddly, just get used to it. Take your time, put the wires in the terminal, get your electrical screwdriver, and just tighten it up like that. The next one, blue stripe in, tighten the terminal, and the last one is the blue there, and tighten up. Okay, on the Waveshare on the other end, we've got a V plus on the left hand side, V minus on the right hand side. So the V minus is going to have the 2 solid green ones, the V plus is going to have the green and white striped. Just tighten those up. Not too much. It's all very small stuff. All I'm going to do now is plug in the router cable into the end like that, and then it's just a case of fiddling it carefully down into the box. To get it in now, I'm just going to push it right up to one side and clip it onto the DIN rail like that, and then just slide it back to the middle. That's the best way that it fits for what I've done there. And then there's a little bit of a loop of extra wire. I could have made it shorter, but it really doesn't matter. Just put the wire down at the bottom in place, and it will be absolutely fine along with the rest of it. I've got the lid here to go on, and I've just tried to offer it up to the Waveshare, and it's just not quite big enough. I think Waveshare need telling about this, because I've seen that they don't quite fit in other DIN rail housings. So it would be nice that they just reduced it by a millimetre or two so that it fit in. I'm going to just file a little bit of the plastic off the top and the bottom of the box to make that fit. Okay, so I've filed out the lid. I'm just ready to put it on now, so that should fit nicely like that. And then I've got a couple of blanking plates just to finish off the trim down the sides, which I'll just put in there like that. And then it comes with fixings, which I think are captive fixings, so they need pressing in like that to start with, one in each corner. And then just use a screwdriver to tighten those up. That's it, a Waveshare in a nice Wilex box. I'm going to put network on the other end. That's the Waveshare device finished. One Cat5 standard patch cable into the inverter end. That goes into the COM LCD port of the inverter, and the other one will go into a network switch, your Wi-Fi router, or a Wi-Fi repeater if you can't get a cable to the Waveshare. All the components for this, to build it, I'll leave in the description, or they'll be in the video somewhere, with the costs and where to get them. The whole thing costs approximately £65 as it is like this. That's the component cost. There's a little bit of software setup to do to get it to run with the inverter and to get it to run with Home Assistant, and I'll show you that next. Really important on this, I'm just going to show you how to put an RJ45 connector on the end of a Cat5 cable. Okay, so this is used for the BMS, it's used for CT clamps, it's used for the Modbus cabling. All the data cables generally are Cat5 or Cat6, and the Solax inverters seem to work fine with Cat5 cable, and that's what I actually ran under my house for my CT clamp. Firstly, the tools we'll need. This is a Cat5 crimping tool, and we're going to be using the 8-pin side of it. The 6-pin is used mainly for telephone. So data network cable uses the 8-pin. These are fairly cheap, they're about £10. This isn't a particularly good one, but it does the job for the times that I need to do it. Secondly, you'll need to strip the outside insulation off the Cat5 cable, and this is a cable stripping tool. And the last thing you'll need are a small pair of side cutters. So fine ones that come together well, fine side cutters, not big pliers. And the last thing, you're going to need some cable. So this is going to be one end of your data cable, and this is a cable relief, and it keeps it a little bit weatherproof. And this is an RJ45 crimp-on plug. They're all the things that you're going to need, and I'll show you how to do it next. Right, so starting with a Cat5 cable, we're going to use the sheathing stripper first, just to take off up to about 5 centimeters of the outside sheathing. So just roll it around with your finger like that. It cuts the outer sheath but doesn't cut the inner cores, and you can see we've got 4 sets of twisted paired cables inside. This extra on here is a piece of string, and this is used so you don't put strain on the cables when you pull them through conduit. So you can just cut that off with your side cutters. Now the first thing to do is not to forget putting on the strain relief, which I should have done already. Okay, so just put on the strain relief first onto the cable, and then just push that along out of the way until we put the connector on. So what's important is the order of the wires inside. We've got orange stripe orange, green stripe green, blue stripe blue, brown stripe brown. All right, and they're going to need to go in a certain order inside the connector. So what you need to do is just spend a couple of minutes preparing the cables, untwisting them, and making sure the order is correct. So I'm going to untwist the oranges, untwist them right back to the sheathing here, as far as you can. That's 1, 2. Untwist the greens. Untwist the blue. They're all twisted at different ratios. It's so that they cancel each other out, so there isn't noise in the signal. So some are twisted tighter than others. And the brown one. Untwisting them right back. So we'll start to assemble the correct order. So we need orange stripe first, and then orange, and then green stripe, and then blue. So the blue one's going to come in here. You're then going to need blue stripe, and then green, and brown stripe, and brown. And that is the order for a standard RJ45 connector. You can see that all the wires are very wiggly And wiggly wires are no good, they need to be straight. So just spend a minute straightening the wires and trying to bring them close together to look like a ribbon. Okay, so I'm just going to use my fingers here to straighten all the wiggles out of the wires. And you can see I'm just starting to get them looking a little bit straighter. Once you've started to get them straighter, you need to bundle them together in the correct order. So keeping the order as it is, just start to bundle them together so they start to look like a ribbon like this. And when you've made a ribbon like this, try to make the ribbon as straight as possible. So just use your fingers, wiggle it from side to side, just bend it slightly and try to get the wires as straight as you can. So they need to be straight and all together, and when you've done that, check that they're still in the same order. So we need orange stripe orange, green stripe blue, blue stripe green, and brown stripe and brown. And they look to be in the correct order to me and are looking very much like a ribbon. Next, take your connector, RJ45 connector. Now many people make a mistake here, they just push the wires in, leave it dangling out of the end, crimp it and hope for the best, and that's not how an RJ45 is supposed to be done. The outside sheathing here is supposed to be crimped inside the connector, and that forms part of the strain relief. So it's important that you measure exactly how long the wires are going to be inside the plug. So bring the sheathing up to here where this ridge is and measure with your fingernail how long the wires need to be at the end. Then if I just switch hands because I'm right-handed, take my side cutters and I'm going to cut them off straight across like that, and then hold them so they don't change position or get out of alignment. Now I'm going to offer them straight into the RJ45 connector without letting go, so they can't go anywhere. It's really awkward if they go anywhere. Now as you push them in, each one should find its own channel towards the end of the connector. And you can see the grey sheathing has gone up to here where I intended, and if you look at the end you can see all the little wires have touched the end. It's important to be able to see them there so that you know they're being crimped into the connectors when you use the tool. So keep that pushed in, wiggle it in to the end, pick up your RJ45 crimping tool, plug it into the 8-pin socket and press the handles together until they touch and they don't go anymore, and then release it and pull it out of the tool. And that is one RJ45 connector crimped on. Bring up the strain relief that you put on before and then just wiggle it over the connector like that. And that is now ready, and you can see all the colours in the right order touching the end, and it's crimped on well. So that's ready for your CT clamp or to go into the BMS port, RS485 or CT port of your inverter. I've just brought the box now, the Waveshare, to the inverter to test. So the end, I've got a patch cable plugged into the inverter end, and I'm going to plug this into the COM LCD port there. Like that. And as soon as I do that, the power light should come on because it's getting a 13 volt DC supply to the Waveshare from the inverter. On the other end, I am going to plug into my network switch like that, and when you do that, there should also be, as soon as it gets a signal, a green link light.
Let's look now at the Waveshare configuration. To configure the Waveshare, you need to download the Waveshare configuration utility called Viacom. Now, I think this is a terrible name for a utility. It just sounds like a dodgy virus from the 1990s. But there you go, there's the link, and you're going to need to put that into your web browser and download the software. So let me find it for you. So there's a web browser. I've gone to the Viacom site there with that link, and you just need to click on this Viacom en.ra here, and that will be put in your downloads. Okay, so they're my downloads. I'll just put that over there and you can see it. Now this is a RAR file, which is a compressed file, so you can't run it straight away from here. You're going to need to open it. Now some operating systems can open it. Mine, I need the WinRAR utility to open it. So if I go to that WinRAR link, you can see here you're going to need to pick either the 32-bit or the 64-bit version for whichever operating system you're running, and click that to download the WinRAR extraction utility. Okay, so I've got WinRAR here. Double click that to install it. Now I've already installed mine, so I'm not going to do it again. I'm just going to show you how to extract the Viacom from the RAR file. So if you just right click it and you can say extract here, and you can see it's put a Viacom en.exe file, and that is the utility to configure the Waveshare device. Okay, so double click that. Now you may have to allow this through your firewall because the Windows Defender or some other antivirus software might prevent it, so you need to allow access for that. And this is the utility, the Viacom utility that you're going to use to configure the Waveshare device. And if you click the device icon to start with, you will see a list of the Waveshare devices connected to your network. Now if it doesn't appear here, you can auto search or add manually. Auto searching will search your network and find any devices that are there. When you've done that, double click on the device that you want to configure and you'll be presented with the main configuration window. There are a few things to change on this window. Firstly, make sure that your network configuration here, IP mode, is in static. Please assign it a static IP address because you don't want the IP address changing in the future using DHCP. So make sure this one is static. You then need to assign the IP address you want it to run on your network. I'm just going to put mine to 192.168.1.113. So this is not part of my DHCP allocation pool. It's outside of that, so it can be a fixed IP address. Underneath there, the port configuration needs to be 502, so change that to 502. TCP server can be left alone. The network mask for most people is going to be this 255.255.255.0, and the gateway is the IP address of your router. So mine is 192.168.1.254. Down to the serial window here, I want you to change the baud rate to 19,200 from the list. And it's going to be 8 data bits, non-parity, 1 stop bit, and again, non-flow control. Up here in the top right corner, this is a DNS server configuration. This is Google's DNS server, which you can leave, that's fine. And then we have Destination Dynamic. From the transfer protocol, select Modbus TCP protocol, and the keep lifetime 60 is fine, and the XTT port 80 is also fine. That's everything on that screen that you need to configure. You then need to move on to the more advanced settings, which is in the advanced screen here. So click the more advanced settings button. There isn't much on here to change except the Modbus gateway type. You're going to need to select TCP to RTU on here. When you've done that, click OK, and then you're going to click Modify Setting here to save that to the Waveshare. To start off with, please log on to your Home Assistant instance. So go and click on your HACS link there. In the integrations, we're then going to add an integration in the bottom right corner here to explore repositories, and you will type Solax into there. So you can see Solax Inverter Modbus is the only result. We're going to click on that one. So just in the bottom right corner here, click Download, and just click the download link because we're going to use the latest version. Configuration for this, we need to first go to the settings, and then we're going to the integrations tab. Now at the moment we haven't actually installed the integration yet, so you're going to click add integration and then type in Solax into the box, and we're interested in the Solax inverter Modbus there. So click on that and you're presented with the configuration page. So at the top it says SolarX. Just leave that as it is and it'll help it work with the other things I'm going to show you later. TCP Ethernet connection is correct. Alright, it's a Solax inverter, so I'm going to leave that, but it is compatible with others. It's compatible with Growatt, Solis, Sofar, and some others. Even though it's a Solax integration, it initially started that way, but William has expanded it to be compatible with other brands. The polling time here, this is how often you'd like it to update, and I'm going to set that to 10 seconds. Now, in your instance, you may have different options available. Do you have the emergency power supply enabled? Do you have a dry contact box on a Gen 4? And are your inverters working in a master or slave mode? Now, mine aren't, so I'm not going to tick any of those. And I'm going to click Submit. On to the next screen. Now, this is where you need to set the IP address that you specified in the Waveshare configuration window. In my example, it was 192.168.1.113. Put that in there now and leave the TCP port as 502 and the Modbus TCP selected there and click Submit. If your inverter's in the garage, you can click Add New Area like this and type Garage, or yours may be in the loft and you can click Finish. It'll appear here in your settings integrations. After configuring the Solax Modbus integration, we're back at the Waveshare and you can see that we've got the power light on red, the link light is now blue, and then the activity light flashes at the polling interval that we set in the integration configuration, which is 10 seconds. And that means that the Waveshare is up and running, communicating with Home Assistant and with the inverter. Now this is live and polling your inverter every 10 seconds and updating all the sensors. Now the sensors are called entities in Home Assistant, and you can check to see how many they are and if they're working by just clicking on the integration. So you can see it says one device, 165 entities, that's 165 different sensors and readings that the inverter is providing through the integration. If you click on the entities, then it shows you a list and all the names of the identities which you're going to be using when you set up your dashboard on Home Assistant. Now this screen doesn't provide the actual readings of those sensors. If you want to do that, just go back to the previous screen and you can click on here where it says one device and it'll show you all the readings, the live readings from the inverter in that list. Home Assistant can be a little intimidating at first, but the Home Assistant team were working really hard to bring the interface up to a standard, making it more accessible to non-techies. It's truly amazing what HA can already do, and it's improving all the time, so please go and support them. And all of this wouldn't be possible without Will's Modbus integration. This provides the interface between Home Assistant and the inverter, so please support Will by using and visiting his GitHub page. If you do buy a Solax system, please join the Solax installation Facebook group for an amazing community of knowledge and support. Thank you very much for watching. Please see the rest of my videos. Like, comment, share, subscribe, and I'll see you in the next one. Thank you very much.